Okay, so this is the second lesson on integration with trig function. Remember that our basic toolkit is really this table that you have in your as your formula sheet. The actual table is a bit bigger, but I just skipped all the stuff that we need for trig. Plus the first one, we're not going to use it, but it's always good to have. And the idea is that if we're looking for, let's say, the integral of minus sine cosine, well, the answer will be the cosine. The integral of minus sine will be cosine. Okay, so these are the functions. That table will tell you the derivative, but it also tells you that if these are you're looking for the integral of those, well, the answer is here. But it's always going to be a bit more complicated, isn't it? So we had a look at the last lesson on what happens when I have like a mixture. What did I have a look at? We had a look at when I have just a sine or cosine, but it was 3x. You know, so we had some constants mixed up. We had integral of sec squared, which is obviously just tan. Integral of cosec squared, which is obviously cotan. We had a mixture of cosine and sine, so cos cube sine x, and that was a little bit tricky. And then we had a look at a situation where is cosine times sine, or sine times cosine with equal power, and or just power 1, and we looked at actually two ways of doing it. One with the textbook using the identity of the double angle, which is this one, and another one which I showed you. Now we're just moving on, okay? So tan square and cotan square. Now if you look here, that's your first place to look. You know, if there was a tan square here, it would just be near immediate solution. But we don't have a tan square. We have a sec square, we don't have a tan square. So normally when you don't, or often when you don't have something immediate, then what you need to consult is the identities, the trig identities, which unfortunately you haven't learned yet, but you will learn soon. And that is also given to you in the formula sheet. So we're looking for something with tan square. And I hope you can see that a little bit here. It says 1 plus tan square A equals 6 square A. Now, why that needs to kind of start putting some not red alarms, but green alarm, good things, because
you have a 6 square.
I've got a 6 square. So I can write this as the that should be actually all right. Let's give it another go. Okay, never mind. Okay, so we're going to have an integral in tan. Instead of tan square, I'm going to write 6 square x minus 1, right? Instead of tan square. And I need to put the x, okay? And then that, when I have something plus something, an integral, that is very easy. That is like your common sense, not common sense, your instinct will tell you the right thing, okay? The integral of the difference is simply the difference of the integral. That makes sense. Okay? Now the first integral, dead easy. The integral of sec square is simple tan x. What is that? That is going to stump a few people here. What is minus, I can write 1 times the x. What's the integral of 1? Because you got 1, right? What?
Not 1.
So let's look at it again. What's the derivative? How should I say it? You're looking for a certain function. I don't know what that function. If I differentiate it with respect to x, I should get 1. It's x. Okay? So the derivative of this function is 1. So that means that the function is simply x. Okay? Alright? So the integral of 1 is simply x. So tan x minus x, okay, that's outside. I mean, what you put in the tan is just the x. The minus x is outside, if that makes sense. Okay, let me just see that this thing is still, it's still recording. Hopefully everything is all right. Okay, let's move on to cotan square x. The x, the same thing. Okay, again, you look here. I can't have cotan square x. I don't even have a cotan x, if I'm not mistaken. I don't. But I can use this identity. Okay, so instead of cotan square x, I'm going to write cosec square x minus 1, right? yeah, minus 1 dx, put that all in brackets, okay, and that's going to be the difference of the integral. So cosec square x dx, should put dx there. Be careful always to write that dx there, okay, some teachers can be very particular, and that is important. Minus integral of dx. And then what is the integral of cosec square?
Minus cot square.
Minus
Cot, not minus.
Minus cot, yes, because here I've got the integral, the cot is the integral of minus cosine square, so the integral of cosine square is minus cot, here, minus cot x, and then I still have minus x. One thing I forgot in both these cases, and you can remind me, c. Okay, we must always add a c. Let's quickly check that I've got the right answer here, and it seems to be fine. Okay. Okay, the next one, you might not be able to see this one with the light, so maybe I'll write it again here. We've got sine square x dx, and we're going to try cosine square dx. Now, when you have a power of a sine or cosine by itself, it's a problem, okay? If you have a sine square x time a cosine, then it's fine. One function will be the function, one will be the function, the other one will be the derivative. But I don't have a cosine x. So we're stuffed, okay? We don't have it here. So if we don't have it here, and we can't kind of split it into one function and its derivative, I mean, you might think, okay, maybe one sign could be the function and the other sign the derivative. Doesn't make sense, okay? So we got to use identity. So we're looking for identity.
Equals 1 minus cos square.
Which one? Which one? This one.
Yeah.
Okay, but you know, so you can write instead of sine square 1 minus cosine square, but then I still have cosine square. The 1 is fine.
Okay.
So we got to look at this one, which I actually mentioned but didn't write last time. It's the cosine double. Last lesson we looked at the double sine angle. Now we've got the cosine double. Now the problem with the cosine double is that we have 3 answers, 3 options to take. So cosine 2a is either cosine square a minus sine square a, 2 cosine square a minus 1, or 1 minus 2 cosine minus 2 sine square a. Now, which one do you reckon will be easier to integrate, the right side or the left side? Any of the one on the right or the left? The left is dead easy. The left is just, it's virtually that, okay, with a constant. So we want to go to the left. So if I have sine squared, okay, I can write that what would sine square will be equal to?
Cosine 2a.
So maybe let's write first of all. So I can say 2 sine square x equal 1 minus cosine 2x. Is that right? Can you see what I've done here? I just moved that there and this one there.
Yeah.
Okay, and then I've got 2 sine square x, or I've got just sine square x, so I can say, I'm going to write that down here, that's going to be half of this, right? It's half of that, so it's half of this. So it's going to be half the integral of 1 minus cosine 2x dx. Okay, now again, why this is good? Because I only have integral of 1 and cosine 2x, that's easy to integrate. So I'm going to write it as half the integral of dx. I want you to get used to this. What is dx? It's just 1 times dx, okay? Right? Minus half the integral of cosine 2x dx, which is a little bit more difficult, but still very easy. Okay? Give me some more space here, okay? So the integral of the first one, what is that? We've done that. What is the integral of dx? X. So it will be x over 2 minus half. Okay, now we need to figure out the integral of cosine 2x. So first of all, what kind of function will it be? Let's try and do it without writing much. What's what's going to be the solution look like? Let's leave the constants for now. It's going to be sine or cosine. The integral of cosine is a sine, okay? So integral of cosine, in fact, it's just sine without minus. So it's going to be sine 2x, right? But if I just left it like that, what will be the derivative? The 2 will jump out.
Yeah.
So I need to have something ready to eliminate it. Not this half, because this half should be there anyway.
And you divide it.
So I need to divide it by 2.
The times the final.
Yeah, times by another half. Can you see that? We are right. I'm hoping everyone else is also right for me not writing the whole thing. Just to get you, I put that half there because it should be there. Then I think in my head, what will be the integral of cosine 2x? It's going to be sine 2x time or divide by something. And then my mind, when I write it first, I write it like that, then I'm thinking, okay, if I do the derivative of the sine 2x, I should get cosine 2x. The 2 jumps up, I need to have something prepared to eliminate, and that's divided by 2. And then obviously plus c, so I'm getting x over 2 minus sine 2x over 4. Let's just quickly check that we write x over 2, they got plus. They got plus. We got something wrong. Let's just pause for a second, we got something wrong here. No, I'm looking at the wrong place. Yes, x over 2 minus a quarter of sine 2x. Perfect. The next one is to integrate cosine square x dx. Okay, now we're going to move from cosine square to cosine 2, cosine double angle. So let's see if we can do that. I'm moving the 1 over to there and then dividing by 2. So now it's going to be 1 plus cosine 2x dx. All of that I should time by half. Okay? Okay, the integral of the sum should be the sum of the integrals, so it's half dx plus half. How do I? Yeah, I'm always going to have cosine 2x, of course, because I'm always going to cosine 2x. Okay, now we've done that. That's exactly the same as that, except that now instead of minus, we have a plus.
Half x plus.
Yeah. Plus sine 2x over 4 plus a c. Plus a c. Okay? Right, let's pause.